This is the 6th grade Chapter 9 quiz review. So it says to consider the picture below to identify the given angles as supplementary, complementary, adjacent, vertical, or none. So number 1 says angle BOC and angle COD. So if we identify those angles, BOC, that would be this one here, BOC, and COD, that would be this one here. So we can see that they're together, they look like this. All right, so they're definitely next door to each other, so they're neighbors. That would make them adjacent, which means they can't be vertical if they're right next to each other. If we're looking for supplementary, we can see that these are not making like a whole straight line there, so that's not going to work for supplementary. Complementary would be a right angle, and that is more than 90 degrees, so that's not going to be it. And again, vertical, they're not across from each other, so it can't be that. So only adjacent, this first T. Number 2 is AOF, so AOF would be here, AOF, and FOE, so FOE would be right there. All right, so that's this angle here. And those, again, are next door to each other. They're neighbors, and so that would make these adjacent. They share a side, or a fence, if you want to think about them. As neighbors. And then you can see, or maybe I covered it up here, but these were together making a right angle, so that means they're also complementary, which means they can't be supplementary. And then because they're adjacent, they're not across from each other, so they're obviously not vertical either. All right, so COB and DOE. So COB is this one again with DOE. This time, I'll do my pen. So BOC would be, or COB would be this one with DOE, DOE right here. All right, so this time, they're not adjacent because I have this one in the middle that's not going to be, they have two separate sides that aren't together, so they're not neighbors. There's this one COD in the middle, so they can't be adjacent. They're not making like a straight line, so they're not supplementary. They're not adding up to 90 degrees, so they're not complementary. And they are across from each other, but they're not directly across from each other. So like these are vertical angles because they're directly across, but these are not. So again, like if I'm looking in my backyard, I see this person, not this person. So these would not be anything, they're none. And then the last one is BOC. So again, BOC, this angle right here with BOF. So this time BOF. All right, so this is getting really messy, but BOC is this one right here, and now I'm doing BOF, so BO, this one right here. That's this entire angle right there. All right, so if this one here is sharing a side with this one here, then that means they have this part in common, so they're adjacent. And then if I put both of these angles together, I can see it's taking up this whole side here, or that would be 180 degrees because this is together making a whole straight line. So these are supplementary as well. Okay, all right, number 5 says to draw a pair of vertical angles. And remember, vertical angles are made by intersecting lines. So I can just draw like an X, and then the angles that are across from each other are vertical angles. So remember, we can kind of see that in how it looks. So if you think of this as the V and this is the A, these are vertical angles. And then these two also, right, are also vertical angles. All right, number 6, determine the value of W. All right, so I want to know what W is right here. But what I can tell is from the picture that these are adjacent angles because they have this side in common. But they're also complementary because they're making a right angle. And I know that right angles are 90 degrees. So I know that together these two angles are 90 degrees. So I first need to know what this angle here is. I know that this one's 56. So I can figure out this angle by subtracting. 90 minus 56. All right, so be careful. Borrowing, 10 minus 6 is 4, 8 minus 5 is 3. So I know this entire angle here is 34 degrees, but that's not my answer because I need to solve for W. So I know that W plus 12, all right, an equation now, is 34 degrees, right? Because this whole thing is equal to 34. All right, and then to solve it, I'm solving an equation, so I'm going to cut it in half, and then I'm going to do the inverse operation to isolate the variable. So the opposite of adding 12 would be subtracting 12. So these go away. This is W, and 34 minus 12 is 22. So W is equal to 22. Number 7 says 2 lines intersect each other and form 4 angles as shown in the figure over here. Find the value of y. So I'm looking at this angle and this angle here. All right, so that's my vertical angles. They're across from each other. So vertical angles don't add up to any certain number. Those are only complementary and supplementary, but I do know that vertical angles are also congruent, which just means they're equal angles. So I can put an equation or write an equation to show that 3y will equal 126. And then I solve it. So I cut it in half. I'm going to do the opposite or the inverse to isolate the y. So this means multiply 3 times y when I have a number next to a letter. So I'm going to do the opposite, which would be dividing. All right, so this is y. Over here, if I'm not sure what to do, I can always tie both. So 3 won't go into 1, it'll go into 12 4 times. And then I bring down my 6, 3 will go into 6 2 times. All right, so my answer is 42. And again, you can always check your answers by going back and plugging in the value 42 for y. So if I multiply 42 times 3 over here, 3 times 2 is 6, 3 times 4 is 12, 126. So then I can say that, yeah, this worked out all right because these should be equal if they're vertical angles. All right, number 8, determine the value of x. So again, I have 2 angles here. They share this side right here, so they're adjacent, but because they're making a straight line, they're also supplementary. Right? I know that supplementary angles, supplementary starts with an S, right? Have to equal a certain number. And remember the hint is if I draw a line supplementary, or draw a line in the S for supplementary, then that looks like an 8. So I'm working with the angle 180 degrees. I know together this is 180 degrees. Well, I need to know this angle. I already know this angle. So what I can do is subtract the 35 and see what's left over. So I'm going to borrow 10 minus 5 is 5, 7 minus 3 is 4, bring down the 1. So I know this angle right here is 145 degrees. That's not my final answer because I'm trying to solve for x, this x right here. So now what I need to do is put these equal to each other. X minus 7 is equal to 145 degrees. So I've made an equation and now I'm going to solve it. Cut it in half, isolate the x by doing the opposite or the inverse. So I'm going to add because that's the opposite of subtracting. And then this side would be x, 145 plus 7. If I add those up, it's 12. Carry your 1, bring down the 1. So x is equal to 152. Okay? All right, moving on. Number 9, angle 1 and angle 2 are supplementary, so that's important. If the measure of angle 1 is 97 degrees, what is the measure of angle 2? That's what that M means. It just means the measure of the angle. And that's the symbol for angle there. All right, so again, supplementary, I can see that that's starting with an S. That's the trick for that is to help me remember that I'm using 180 degrees if they're supplementary. If I drew a picture of what was going on here, one of these is 97 degrees and one of them's not, right? But together they make 180 degrees. So I'm trying to find this one right here. So I just need to subtract 97 from 180 degrees and figure out what is left over. So this becomes a 7. 10 minus 7 is 3. To borrow 17 minus 9 is 8. So 83 degrees is the measure of angle 2. Right? Angle 1 and angle 2 are complementary. So again, I have 2 angles. They're complementary. That's my key there. So they're making a right angle. One of them is 21.5, and this other one is the one I'm trying to figure out, is the measure of angle 2, this one right here. All right, in order to do that, I just need to subtract from what number? Well, complementary, remember that, the trick for that is it starts with a C. So I draw a line here, it looks like a 9. That helps me remember they're 90 degrees if they're complementary, and then I need to subtract 21.5. Now be careful, because this has a decimal, I need to line up my decimal when I'm subtracting. The 90 does not have a decimal, so I have to give it a decimal, make it 0.0, and then line it up, 21.5, and subtract. Right, I'm borrowing, so I have to go all the way to the 9 in order to do that. Makes that a 9 and that a 10. 10 minus 5 is 5. 9 minus 1 is 8. 8 minus 2 is 6, and I bring down my decimal. So 68.5 degrees is my answer for the measure of angle 2. Number 11. I have an obtuse scaling triangle. One angle is 24 degrees, another angle is 105 degrees. So if I draw a picture to sort of figure out what's going on here, one of these angles is 24, one of them is 105. What is the measure in degrees of the third angle? So I'm looking for this angle right here. All right, so again, it's important to note that the angles of a triangle, if I add up all three angles, this will always be the number 180. It's just something you have to know. So I want to know if I take out these two, what's left for this one. So first I need to add these together, 105 plus 24, and that would be 129, and then that's the number I'm going to subtract from 180 to figure out what's left for this one. So that becomes a 7, 10 minus 9 is 1, 7 minus 2 is 5. That leaves 51 degrees for this third angle. All right, and number 12, I've got an acute scalene triangle. One angle is 24.8 degrees, another angle is 74.3 degrees. What's the measure in degrees of the third angle of the triangle? Okay, same kind of problem, only I know if it's acute scalene, that means all the angles are acute. So one of them is 24.8, one of them is 74.3, and then this third angle is what I'm looking for. So same problem, it's just got decimals this time, so just be careful that you line up your decimals. 24.8 plus 74.3, that's 11, carry your 1. 1 plus 4 is 5, plus 4 is 9, 2 plus 7 is 9, bring down your decimal, 99.1. All right, so that's what these two are, but I want to know what this one is. So I still have to subtract it from the total, which I know in a triangle is 180 degrees. So minus 99 up 0.1. So if I'm going to line up my decimal, then I'm going to have to make 180 into 180.0 so that I can subtract. All right, I've got to go all the way here to borrow. So 10 minus 1 is 9. 9 minus 9 is 0. 7, let's see, make that 17 minus 9 is 8. And then bring down my decimal. So what's left over is 80.9 degrees is my answer. And again, if I wanted to check these, what I would do is add up all three numbers and make sure that they equal 180 degrees. All right, so 8 plus 3 is 11, plus 9 is 20, carry your 2. 4 plus 2 is 6, plus 4 is 10, carry your 1. Plus 2 is 3, plus 7 is 10, plus 8 is 18. Get my decimal. All right, so do these together equal 180 degrees? Yes. All right, so then I'm correct. All right, determine which of the following would form a triangle. Why or why not? All right, so when I have three sides and I'm trying to decide if they make a triangle, then I have to remember the rule we talked about. So three sides in a triangle will always have three sides. The two shorter sides have to add up to be greater than the longer side. So we did an activity, hopefully in class you got to do this, where we showed you that if the shorter sides aren't longer than the third side right here, then they don't reach far enough to close and make a triangle. Okay, there's not enough distance, or there's not enough length in the sides in order to make that triangle come together. Sometimes it just comes straight together and it looks like a straight line. All right, so what I want to do is check the two shorter sides, so that would be the 3 and the 6, and see, are those longer, are they bigger, are they greater? This is greater than 10. Well, what's 3 plus 6? 9. Is 9 greater than 10? No. All right, so then this is not going to make a triangle. These won't reach in order to close the triangle together. So is this a triangle? No. 3 plus 6 is not greater, so I'm going to cut through that to show that they're not greater than 10, and so no, this would not be a triangle. All right, what about 14? Now let's check again my two shorter sides. So 4 plus 6, is that greater than 8? Is 4 plus 6 is 10? Is 10 greater than 8? Yes. Okay, so if that's true, then yes, this can be a triangle. Right? On the next one, I'm going to again look at my two shorter sides. So my shorter sides are 8 and 11. I'm going to add those together. Is 8 plus 11 greater than 19? Well, 8 plus 11 is equal to 19, but is that the same thing as greater than 19? No, equal is not the same thing as greater. It's got to be greater, so this is not a triangle. All right, on 16, I have my shorter sides are 3 and 7. 3 plus 7 is 10, right? is that greater than 9? Well, yes, 10 is greater than 9, so yes, this could make a triangle. Okay, so just remember that property. The two shorter sides are the sum of the two shorter sides has to be longer than the third side. All right, take a look at the bottom. Classify each triangle by its angles, which are acute, right, or obtuse, and by its sides, equilateral, isosceles, and scalene. All right, so just like we have two names, a first and a last name triangles have two names also. So I'm going to identify both names for each of these triangles. All right, so by the angles, I can see that none of these angles are more than 90 degrees. All right, if it's 90 degrees, it has to have that little box, okay? And if it's obtuse, it's going to be bigger than 90 degrees. So these are all less than 90 degrees, so that means it's acute. All the angles are acute. And then if I classify it by its sides, this line right here, remember, since these are all the same, line, the little tick mark is the same for all of these, and that means all these sides are the same. And when all the sides are the same, it's called equilateral. Okay. On 18. Now 18, they didn't give me any clues, so I'm going to have to look at it. First, by the angles, I can see that that's an acute angle, and that's an acute angle, but if I look at this one, okay, a right angle, remember, it's like a straight line here. All right, so this is more, it's going past that corner, right? So this is angle right here is obtuse. So this is an obtuse triangle. And then I want to look at the sides, and I can see that this side is not the same length as this side, and this side is not the same length as this side. So if all the sides are different, then this is also called a scalene triangle. Oops, I spelled that, scalene. Okay. So again, I'm continuing with classifying triangles. So this one, I have several clues. These first, if I look at the angles, this box right here tells me that that is a right angle. So this is going to be a right triangle. And then I want to look at the sides because these all have a different number of tick marks right here. Then that means they're all different lengths. So that would make this a scalene triangle. Right, and then on 20, they've given me angle measurements. So that's going to help me with the first part, acute, right, or obtuse. So if I look at all of these, 75, 75, and 30, all of these are less than 90 degrees, which makes them all acute. So this is an acute triangle. Remember, obtuse is more than 90. None of those were more than 90. And then I have to look at the sides. Well, this is kind of tricky because they might look kind of like they all have the same side. But I know that the property that we talked about that relates the angles and the sides tells me that if I have two angles that are the same, the angles across from them, the sides across from these angles are also the same. Because this is the same as this is the same as this, all right? Because this number, this third number, is different than these two, then this side is going to be a different length. Now, it's not a great picture because they may look very similar in length, but because I have to go with the numbers, this tells me that two of the sides are the same, but one side is different. And when that happens, when two sides are the same, it's an isosceles triangle. Okay, so all sides, two sides the same, no sides the same. All right, on 21, write and solve equations, determine the value of x and y in each figure. All right, so this is kind of what we were just talking about. This side must be equal to this side because they have the same mark, the same tick mark. All right, so then this has to equal this. So if I want to write an equation, 12 has to equal this part right here, y plus 6. Then when I solve it, I'm going to cut it in half. I'm isolating the y, so I'm going to do the opposite of adding 6, which is subtracting 6. So 12 minus 6 is 6. Y is equal to 6. All right, and 22. Again, these sides are the same, so these angles are the same. So that means 3x is equal to 75. This is an equation. To solve it, I cut it in half, and I'm going to isolate x. This means multiply. A number next to a letter is multiply. So do the opposite. Divide by 3. Right? This becomes x here. This, if I'm not sure what that is, but think of quarters, I can tie both. 3 will go into 7 twice. 7 minus 6 is 1. Bring down your 5. 3 going to 15. 5 times. So x is equal to 25. All right, number 23. These tick marks right here are all the same. So that tells me that all the sides are the same. So this is an equilateral triangle. I know if all the sides are the same, then all the angles are also the same. All right, they didn't tell me what the other angle was, what these angles were. So I have to know something else about equilateral triangles. I have to know that the measure of the angles in an equilateral triangle will always be the same number. Now, if I forget what that number is, what I can remember is that all the angles in a triangle have to add up to 180. So if all of 3 of these are the same number, then what I could do is just divide 180 by 3 to remind myself what number these have to be. So 3 will go into 8, it'll go 18 6 times. And bring down your 0. So 3 going to 0, 0 times. All right, so if I've forgotten that the angles in an equilateral triangle are all 60, then I can figure it out. So I know that this is the same as this and the same as this. They're all the same because all the sides are the same. So since I want to know what x is, I'm going to set 6x equal to one of these. And since they're the same, it doesn't matter. To 60, and then solve it. All right, cut it in half. 6x means 6 times x, so do the opposite. X is going to equal 60 divided by 6. Again, if you forget, typo, 6 will go into 6 once. Bring down your 0. 6 will go into 0, 0 times, so 10. All right, and then the last one, 24. These, again, are reminding me that all the sides are the same. So I know that this side has to equal this side. So y minus 7 has to equal 15. And then that's just an equation. I'm going to solve it. So cut it in half. Isolate the y by doing the opposite. The opposite of subtracting 7 is adding 7. This becomes y. Over here, 15 plus 7 would be 12, 22. So y equals 22. All right, so that's the end of the Chapter 9 quiz review. Remember to study it, maybe redo some of the problems, and we'll see you in class tomorrow. All right, bye.